we're going to talk about, oh, it's so small. We're going to talk about, we're going to talk about JavaScript modules. Let's go back to the Webpack Starter template. All right, so at the beginning, I talked to you about how JavaScript, everything is basically a global scope unless you put function wrappers. Oh gosh, how many things do I have open? Everything's in a global scope unless you have function wrappers, and you have to worry about that. That's true for a JavaScript script file, which is primarily what you guys have been introduced to, except that in Webpack, it's not. Node started with the concept, or quite a while ago, they started with the concept of, it was clear that JavaScript needed dependency linking and modules. So I can import symbols from one file and use them in mine, integrate contract. The problem being two different specs emerged for two very different use cases. One use case was designed asynchronously for the browser. So I want to import this other JavaScript file. When it loads, then I want to run this code. Okay? So that was one. And then the other one was designed for Node.js, which is asynchronous. Import this code, immediately run. Let me tell you, from the developer experience, synchronous code is a lot nicer to work with. From a performance standpoint, asynchronous is the way to go. So that's kind of the story behind that. Both of those formats went out. And so for a long time, asynchronous was used in the browser, synchronous was used in the Node. I'm not going to talk about what the asynchronous in the browser looked like, because that spec is basically dead. The Node spec was common JS modules, or abbreviated CJS. And that's, you've seen me use it in class. Const foo equals require bar. That's kind of the syntax of bringing in a module symbol. And then I can do foo dot bar, whatever. I mean, I imported a symbol. So it could have been a function call. It could have been a primitive. It could have been an object with properties. It could have been a class I extend. It could have been any of those things. That's all it was. And the other thing is, in Node.js, everything itself is a module, and modules have their own unique scope. So if I do var foo here, and inside this statement, inside this bar module, they had a global foo symbol. These two things won't collapse, won't conflict, because they're in different scopes. Each module has its own scope. Okay, so this is what Node did, highly popular. Then there began to be build tooling, which converted these common JS modules, bundled them together, and allowed them to run in a browser. Now, if I actually, and there's still a way it's deprecated, but where I actually to do this naively in a browser, these synchronous imports, so if I had to require another JavaScript file that wasn't loaded in the browser yet, and I synchronously blocked to wait for it to happen. Funny thing about JavaScript in the browser, for the most part, everything runs in a single thread. So if you do a lot of work in JavaScript, you blocked the UI. So if you've ever been on a website and like your browser performance and your UI, your mouse gets really laggy, you can't click on things, you can't do things, that's what you're seeing is that synchronous thread operations. Easiest way to do it is create an infinite loop, but browsers are pretty good now about saying, hey, this script's taking a long time, do you want to kill this page? So that comes up a lot. So you have to watch that. So that synchronous loading, blocking the UI thread while I load a remote resource is something you do not want to do. And so browsers really discourage that. But the way that this worked is we could use this as build tooling. So build tooling would see this, and it would bundle all these imports, all these module imports together in a single file. And we deliver one file. So you were guaranteed they were already in the browser loaded, and all you had to do was go get the correct symbol in the correct spot. And so that that's how that was happening. So there was a number of tools that did this. Browserify. There were several others. I can't even remember them all. And then along came Webpack, and it does this for us built in to the build tooling. So Webpack does this too. Well, 2015 spec of JavaScript. My other window. JavaScript got proper modules built in. However, while everything else in this spec is usable by modern browsers, no problems in the browser today, modules have been the exception. Because while the spec stipulated what a module should look like, it did not specify how you load one, which is kind of an important thing. So, export and import keywords were how you do modules in JavaScript. But those keywords are only valid inside a JavaScript module. So you notice I have a chicken and egg problem. I can only use import and export keywords inside a module, but well, then how do I load a module to begin with? So that's kind of the no man's world we've been stuck in for a long time. So in this past few years, we've finally gotten a proper module loader in the newest browsers, but we're still way early in it, so we still rely on build tooling to convert this for us. And Webpack is not a transpiler. Remember I said it would, later in the class we'd wire it up so you can write new JavaScript syntax to run in old web browsers. Webpack doesn't do that built in, except it does do it for the modules. So you can use the import and export syntax in Webpack today, and we can also use the require and the CommonJS syntax, and we can mix the two in the same build all day long, and Webpack itself will convert those for us and normalize that. So this is a big benefit to us. One of the major differences, or one of the things that was important in ECMAScript 2015 modules, or ESM modules, is that they're static. So this right here must be a string literal. I can't put variable foo there. Has to be a string literal. And I can't dynamically change it in any way. And it also has to be at the root scope of the module. Like I can't nest this inside a function or an if statement or anything. It has to be there. So the idea being that at build time, you always know all the modules that are being imported or exported, and you can make a build graph of your entire system. And this is static and able to be analyzed before it actually executes. You know fully everything about it. If this were to be dynamic, that would totally go out the window. Okay, so CommonJS, that's not true. So I can make this be, I can't say bar path, and I can say bar path equals. So that's perfectly valid to do in CommonJS. Now, Webpack itself won't like this because Webpack wants to statically analyze all your imports and exports. So it doesn't like that either. So this is not a great practice. But CommonJS does allow you to dynamically import things inside statements. So I could say let bar if some test bar equals. So I could do that in CommonJS, and that's perfectly fine. Nothing wrong with that. This is kind of the scenario or the world we're living in. That's kind of the differences between CommonJS and ECMAScript modules. For the most part, it's starting to change, but for the most part, anything you pull down from NPM or install from NPM is going to be a CommonJS module. More written, sourced as ECMAScript modules, and they use a build step to convert them to CommonJS before publishing to NPM. but some of them, but everything is pretty much CommonJS. That probably won't be the same. That statement probably won't be true at this point next year, because Node is this close to finally having module support, ECMAScript module support built in. But that's kind of the way things are. So let's play around with modules a little bit. Open up the project again. So one of the things, one of the things that was interesting in a script, anything that I type in the global scope like this is global and is also a property on the window object. So if I did console.log window.foo right here, remember window is the global object, this foo points at this variable and it would log out bar. Okay, in a module scope, this is no longer true because modules have a unique scope. And in Webpack, everything is a module. So this is now a module. So this is one of those cases where now foo isn't. So if I want to make foo globally accessible, which pay attention because this is part of your homework assignment, then I have to explicitly set it on the window object. So I can say window.foo equals foo. And now I've explicitly elevated it to be global.
Yeah, I was able to get the Webpack server to run, but I could never access map on the browser when I was testing it. So I had to actually import the script tag into the HTML to directly access.
Yeah, so this is what you need to know.
Okay, so do I just change that thing and then update?
You can do it either way you want. This is probably this is by far the easiest way, and then you don't have to mess around in Webpack. So this is how we elevate the scope of things, but in this case, we have to explicitly set what we want to pollute the global scope with. So we've exposed specific things in there, and foo is basically now, not basically, foo is a private variable for us until we did this. Like there's no way to get in there and change that. Yes.
So now if I update foo, will it also update the global foo object, or do I have to update that separately? Do I have to do window.foo and set the new value that way?
How many of you had C++? It's pretty much everyone here. Okay. So we have to talk about things in terms of pointers for you to understand this. When I had classes of computer science majors who came from Python and Java, this was really hard concept for me to talk about because there's no pointers. Well, there are, you just don't know about them. With C++, you finally know about them again, which I think was kind of the point in switching back. Not a fun language, but it does do a great job of teaching that. I have var foo, and that's a pointer to some memory location that has a string bar. That's what that is, okay? And then I said window.foo equals foo. I'm pretty sure now this also points to the same location of bar. So if I now say foo equals as, I did not change that pointer. I did not change the window.foo pointer. It was still pointing at the string of bar. Does that make sense? So I copied the pointer when I did that, is basically what I'm saying. However, now things are a little bit different. Because I pointed, now window.foo is pointing at this object reference, and I changed a property on the object reference, I did update the binding. So now if I console.log it would output Baz. Okay, did that make sense? Correct. Object properties are dynamically updated, but variables are not when you assign them to a property. And the easiest way to think about that is via pointers. You can. You totally can. No. Okay. No. Remember we talked about prototypes. So every object in JavaScript has a prototype of some sort, unless you explicitly said it didn't. There's a use case for that. But for the most part, everything has a prototype. And so when I say foo.bar, what the interpreter does is say, does the foo instance have a bar property? If so, use that. If it didn't, it goes to the next one. Does the foo.prototype have a bar property? If so, use that. If it doesn't, does the foo.prototype does foo's parent, that's the best way to describe it, have a bar property? You can think of this in a class extension method. Yeah.
I think I'm thinking of you can't add an object, or you can't add properties to an object.
No, you can do all of these things. Yes. So you can add properties after you've instantiated something. No, const has nothing to do with this. By the way, if you want to think about const, we need to talk about pointers as well, because that will start making const make sense to you. So again, thinking about pointers, if all of a sudden this becomes const, I should make this be foo2. So I can't foo2 equals this. That's illegal because foo2 is a const and I'm changing the binding. But foo2.bar equals baz is perfectly legal because I wasn't changing the pointer that foo2 referenced. Make sense? That's how you think about const. This is so much easier now that I can actually talk about pointers. This is also one of the things you want to remember if we talk about JavaScript functions and pass by value, pass by reference. You can't specify how you do that. I mean, it's just internally done for you. But primitive types are by value, objects are by reference. So if you add properties to an object in a function, they'll exist outside the function. So that's how that goes. Okay, back to modules. So let's have a couple different modules. CJS1.js. So let's start with CommonJS modules. CommonJS modules have a couple variations. I'm going to not give you the explicit full spec. I'm just going to talk about the most common use case. So we've already seen import in that I can require it in. Exports are assignments to the module.exports equals function return hello world. Okay, so module.exports, and in CommonJS modules, I can have one export only. Now, I say that. This is good. I still only have one export, but I added a property other to the function. Do you understand what I'm saying? JavaScript is a loosey-goosey language. I can add properties wherever I want. So this is perfectly fine, and this is done all the time. Also, module.exports is predefined as an empty object, so I could just do other module.exports bar equals bar. Okay, so this is okay, and so this looks like I have multiple exports, but I'm exporting one object. I mean, this is equivalent to if I'd done this. That's what that is. So it's tricks on the thing, but in general, there is only one export for CommonJS. Okay, so here we go. So module.exports, I'm going to export a function that says hello world. So in the hello world JavaScript, not the best name, let's say const hello world equals require CJS subjects. And why I started that with the dot slash, I'm going to defer from. say, let's do everything we had done before. So const span or div equal document dot create element div dot inner text equals hello world function document dot body dot append child div. Oh, can't resolve CJS because I think I named it CJS1. Yep. So that was static analysis. It knew at build time that I didn't have that. Now we're good. Modules is not defined. Instead of module.exports. Div.inner text is not defined. Oh. Not a function call. Sorry, I'm not thinking straight. Hello world. Okay. All right. So now, in order to do this with ESM modules, let's do the same thing. And let's make ESM1.js. So yeah, ESM modules are always strict mode. Always. You don't have to do anything. CommonJS or not, I should have put you strict at the top, but function hello world. And I'm just going to put export default so that I can do that same one-line thing trick that I did before. Now, nice thing about Webpack, I haven't changed anything yet. It didn't rebuild. Webpack starts at my entry point, which we said was hello world in the config, and it looks at the modules that you referenced, and then it opens them, and so it walks this graph and only includes files that it found. So it didn't blindly just say, give me all your source files. So if you quit using a file, it won't be included in your bundle. This is awesome because size matters for performance. So it's not being built or included here because I didn't reference it. So I have to go back over here, and instead of that import statement, I want to do import hello world from ESM1.js. It's probably so fast that I can't tell it. We should probably change the output just to make sure it did it. There we go. Okay. Now, one peculiarity on CommonJS. Notice I have this keyword default here. Okay. ESM modules are designed to make it easiest to use the default export. But I can have multiple exports from a file. Unlike CommonJS, where we only had one, I have multiple exports. So I could go down here and say export other, let's do export const other equals. But I didn't import it over here. So import hello world from is the default import. If I want other named, there's only one default. If I want other named ones, I have to use a little bit of a different syntax. Import other from. So the reason this isn't an object, it's not exactly, but it looks a lot like destructuring, which we haven't talked about. Have you guys used destructuring in any other language you've been in? Okay. Quick note on what destructuring looks like. Let's say I say const foo equals r as. Now let's say I want to just create a bar. Let's say I just want to create, I don't want to do foo.bar and foo.baz. I just want to create local variables to reference it. This const bar equals foo.bar, const baz equals foo.baz. In fact, that's the normal way you would see it, but that's kind of pedantic and longer than I should do. So destructuring says const bar baz equals foo. And you have to kind of think backwards. And in this case, this is actually, in fact, this is the most common way, but this is the shortcut. That says create me a variable bar that's also the same as the bar property. If I want it, and you have to think, the reason you have to think backwards is we're on the left side of the expression. If I wanted to alias this where it wasn't bar, I would say bar1 as one. Again, this is a head trip, think backwards. Now I have console.log bar1. And if I did console.log bar, I would get undefined. I mean, I didn't make that one. So this says take the bar property off the foo object and make me a local variable called bar1. That's why I said think backwards. Yes, destructuring is a head trip until you start using it on a regular basis. But 90% of the time, you're doing this, which is not near as confusing, right? You're just saying create me a bar, and now down here, bar1 doesn't exist, but bar does. So that's what's going on. So when you're up here, now that I said kind of like destructuring, you can't do formal destructuring up here. Now I could, if I wanted to combine these into one statement, I could do default as hello world. And that keyword as is different, is only valid in this module import syntax. It's not valid down here. This is not true destructuring, but this is that aliasing. And this is why the default, I aliased it up here as hello world just implicitly. That's why everything in ESM modules is designed to make you use the default module, default export. All right. Questions on the ESM modules or how this kind of works? Yes.
Could you have used the as keyword with the other, so like other as baz, or like to
yes,
that?
yes.
I didn't know if it was just the default.
No. Yeah, that's perfectly fine. But again, as, don't go using as everywhere. As is only valid in this import statement. Down here, it was like I showed you. The right side of it is the.
What is the head trip?
Down here,
Yeah.
I created a variable named bar1, which is the bar property on the foo object. But it's on the right side of this expression, which is weird. But we're destructuring on the left side. That's why it's different. So. It's literally the same as if it's a pointer. So it's literally the same as if I had done const bar1 equals foo.bar. And now if I change foo.bar equal other, bar1 did not change. Because again, it's that pointers thing. But these two are totally equivalent. And in fact, when we talk about transpiling, this is basically syntactic sugar. Because a transpiler will say, hey, Internet Explorer has no idea what this syntax is because this is ECMAScript 6 and it only knows 5. So I'm going to change it into this for you automatically. And that's what a transpiler will do that for you. So this is just syntactic sugar. So modern JavaScript, and the reason, we're starting with Webpack for a reason. Modern JavaScript and modern projects are written with modules to express all their dependencies. That way, and Webpack does more. Webpack's not the only tool that does this. But if I never reference the other export, then that gets deleted and removed from my bundle completely. Now, this is true of ECMAScript modules because they're static. This is not true of CommonJS modules because they are dynamic, and so it doesn't have enough information to do that. But extra properties and extra exports in ECMAScript modules are, it's called different things. Tree shaking is the most common term. So it's basically like, I picked up my whole graph, shook it, and anything not attached fell on the floor, and what I was left with is actually got deployed. That's the way to think about it. So if you don't reference a particular export or a particular file, it doesn't get included in your output bundle, which is awesome. Yes?
So if you import something and you don't use it after you import it, does it get removed?
Depends on the tool. I don't think that's true in Webpack. If you import something into like your main file that was used, I think it might stay. We'd have to run some test cases. I think it might stay. If I don't import it though, then it would. We'd have to check though. I'm not 100% sure on that, but I wouldn't expect it to just get removed. Other questions on these? So I kind of expect everything you do is going to be a module. Now I do want to go one more, and this is a little bit harder to do because we don't have an HTML file. So I'm just going to go dink around in the browser. We can do it here. So this is all static imports. But remember, because I use the import keyword, I am an ECMAScript module. That also means because I use this import keyword, I don't want to use module.exports because that would be mixing module types. Totally fine to use require to import something, not okay. If I used import or export, I need to use export to export things. But I can mix import types all day long. Let's talk about the asynchronous mode. So the official way now to get around this concept, there's two ways. One, if you put in your browser, if you put a script tag and you put type equals module on it, one, you just made that script tag asynchronous. And two, you can now use import and export keywords in it. So newest browsers only, but that works. Script type equals module. That's the official way to start a module chain. Or there's a new dynamic import statement / function, although it's not exactly a function. Let's use that. So I can say import parentheses. Now all of a sudden I'm in an import function call, which is not the same. And I want to do esm1.js. Okay. And then now this uses promises, and we haven't talked about those yet, but they're asynchronous. Thenibles, because they have a then method. After it's imported, then call my callback. And I'm going to say object, and here's why. Remember when I said, I'm going to move all of this in here. Remember when I said that multiple exports? Well, that's mostly true, but in general, it kind of does the same thing that CommonJS did in that you have a root module object that those exports are all properties of, including the default. So since I want the default object, I can go down here and say const hello world equals object, or actually I could destructure it. So I got the hello world. That looks funny, so let's just do this. Hello world object.default. Remember, it was the default export over here. So I'm bringing in the default by that. Now, If I want to get really tricky and write clean code or just simplify code, I can do my destructuring in the arguments of the function. That's totally fine. So I could say default : hello world. But arrow functions being what they are, I need an extra set of parentheses there to do that. And the red squiggly lines tell me that. So this should totally import it. So let's look down here at what built. I'm going to run it from scratch. Now you'll notice, and this is the joy of Webpack, I have two bundle JavaScripts outputting, bundle and zero.bundle.js. This is the absolute sheer beauty of Webpack. Because I asynchronously imported code, it assumes I want to lazy load it and not slow down my main build. And so it made two output files. So when we go over here and look, I still have hello world. And I look at my network requests. Let's go. Here's my hello world that got out. And up here, once I get past the Webpack bootstrap and all the dynamically updated my page code, here it is. See, it put a nice little comment here to tell me, well, that was my import statement. Then there's my destructuring, and here it is. So it literally dynamically loaded two files to do that. And that's why what makes Webpack reign supreme, is because it's so easy to do code splitting, which is the technical code splitting or lazy loading. I want to create different output bundles and load them dynamically. Webpack does that for you automatically based off static analysis. So by looking at how you imported it, just by changing how I structured that import statement, it actually let me divide up my code. Why this matters? Let's say you have a really large application that has, let's say, 9 megs of JavaScript. I have 2 applications like that deployed right now, by the way. So simply by changing how I structure my code, now I can't just go change the import statement. I have to make the code handle asynchronous imports. So it was a little bit of work on my part. Not a lot, though. Simply by changing that, Webpack sees that these modules are only used after that dynamic import. And it says, OK, we'll just put all that code over here in a separate bundle, and you can load it on demand, and it splits it up. Initial page load, and then loads the other later when I'm on demand when I need it. So that's a thing of beauty. So import like this is the new way to do that. So this is the ESM module way to do it. There is a CommonJS has a similar concept. It's not based off promises, but based off callbacks. So it would be require.ensure. And then the first argument is an array of modules that I need to depend on. So let's say cjs1.js. And then a callback function that takes a single argument called require. That's important because in here, I'm still going to require const hello world equals require. And then we'll put all of this code in there. And Webpack doesn't care. It's going to treat them pretty close to the same. They're not identical, but it's going to pretty much do the same thing. And you notice it says hello world and not hello world 1. But that was the same way. So CommonJS uses required.ensure. ECMAScript modules use the import statement function call thing, not the import from. Those get really confusing, but those. One is promises based in asynchronous. The other is a static import. So for your code that you're going to write, I would prefer you stick with ECMAScript modules. Because 2 years from now, people are going to be like, you're still using CommonJS? You shouldn't be doing that. I mean, we're all going to be in ECMAScript modules. And they are the preferred path. They are more restrictive, but they're more restrictive for a good reason. They allow us, it's much easier to, forces us to better code and forces us to code that can be statically analyzed. That's a big deal. All right, questions? This should start between the latter classes, this should start making what you see make a lot more sense now. All right. So just sum up, everything in Webpack is a module. Development is around the modules of some type, CommonJS or Javascript modules. The idea of going and getting jQuery off a CDN and just plopping it on your page is just pretty much dead. Don't do that. Yeah, you want to do everything. Now, it's still perfectly valid to npm install jQuery and then import it as a module. That's fine. That's the way you want to do it. But just to go reference someone's CDN in your page means you're not optimizing your site, not optimizing your build. So any performant app has a build step. Now, you will see arguments on the internet that says with HTTP2, we'll talk about some of the changes with that later, and with ECMAScript modules, that you shouldn't need a build step anymore. This is completely false. For a performance standpoint, any large app is going to have, any significant size app is going to have at least hundreds of imported modules, if not thousands. So you need a build step to do that tree shaking, to trace through dependencies to get exactly what you want, and to get your, and also to do bundling so that each file that you reference doesn't actually become an individual file on your website, because that round trip of loading all those files is huge performance overhead. So there is kind of a not Goldilocks zone of how much do I bundle, how much do I split, but not bundling at all is definitely not what you want to do. So keep that in mind. Webpack does have a, I wonder if I can get to that real quick. Webpack does have a little, let me see if I can run it. You're not going to be able to see this command, but that's okay. Webpack has a profile flag, which will output kind of information on your build, and then it has a nice little graph analyzer that takes that and shows you. So this is a very small project, and each one of these boxes is a different module file. This is a very small project, and what I mean by that is the different colors are different split points. So this is one file, main.js, and here's the 0 bundle and the 1 bundle. So this main.js file gzips down to about 31, 32K. That's super small. Oh. Once we get to megs, we've got problems. So this whole thing is really small. That's what I meant by thousands and thousands and thousands of modules. This is a small project. Imagine where we're going to get to. But build tools handle this for us. All right, that's it. If for some reason you don't have a homework assignment showing up on GitHub, you need to talk to me or get me your GitHub username.